Welcome to another video of the tutorial series on Resource Modeling Solutions Automated Modeling Platform, AMP. In this video, we'll explore the connectivity between AMP and RMSP in more detail. By the end of this video, you'll be able to set up your own projects leveraging RMSP tools and workflows. In this video, we're going to revert to the project we've set up from scratch earlier in this tutorial series, new STM workflow example. If you've been following along, your project should contain 2 Blastholes files, 2 Python script files, the project parameters and utility functions, and a set of 4 Jupyter notebooks, project setup, parameters, estimation, and the model's checks. Let's go ahead and delete the second Blastholes file. We had loaded this just to present 2 different ways of loading files in AMP, and we don't need these duplicated datasets. Let's start with our first notebook, 01 setup. It's worth noting that the notebooks are editable in AMP. So if I want to add a markdown cell, for example, or a code cell, I can do that as I would in the Jupyter environment. You can simply come here on the right-hand side of a cell and say insert cell below, or insert cell above, and then you can also delete a cell, or you can duplicate a cell and you can move a cell up or down. I can run an individual cell by pressing the little play button at the top or by pressing Shift-Enter, just like in the Jupyter environment. To connect RMSP with the AMP user interface, we use rmsp.connect. We now can see that this notebook is now connected to the project new STM workflow example in the region AMP video tutorials. We can list the resources available in AMP by using rmsp.amp.list_resource_types. This list mirrors the project tree structure and shows the resource types in alphabetical order. So if we toggle the empty folders on, and if we open all of the folders, we're going to see the same resource types listed here and in the project tree. We can also use rmsp.amp.list_resources to list all resources available in this project in AMP. So you should be seeing the Blastholes as point data here. You should be seeing all 4 notebooks, and you should be seeing the 2 Python scripts files. Continuing with the setup of our RMSP workflows, let's now import the project parameters. Now, if I run this cell, I'll get an error because AMP can't find this Python script file. So it says no module named project params, even though I have this file here loaded in AMP. To expose the Python script files to AMP, we need to make an addition here. So we need to have this cell added before importing the project parameters file. We need to say rmsp.resource.fromRemote and project parameters.download. So this, of course, is the name of the Python script. And now if I run these 2 cells again, I'm not going to get an error. So importing the project parameters here and defining our variable through the project parameters file in var equals pars.var. We can inspect the project parameters file. This is a typical parameters file that you would normally set up for any project in RMSP. We're defining some global parameters, such as plotting the grid and standardizing the section plot figure size at 8 by 8. And we're defining variable parameters for the copper variable, including color and axis limits, the unit, the color map, and the label template. If we go to variable parameters on the left-hand side here in the main menu, we'll see the parameters defined for copper in the project parameters file. The same color map, the color limits, the axis limits, and so on. These are the same specs that we've just loaded from the project parameters file. We can use the same rmsp.resource.fromRemote utilspy.download for the Python file containing the utility functions, followed by importing a specific utility function called checkGetResource. Let's inspect this Python file for a little bit. This function here is quite clever. Its premise is that AMP is the single source of truth for data. Basically, we check the list of resources available in AMP. If a given resource is available in AMP, we're going to use it. We then get a message saying that we're loading a specific resource from remote, that is, from AMP. On the other hand, if a given resource is not available in AMP, we're going to create or calculate it. And we get a message saying that we are creating a new resource and uploading back to remote, that is, back to AMP. Going back to our notebook, we'll now load the Blastholes imported into AMP. To do that, we use RMSP.fromAMP and we call the file called Blastholes. This exposes the Blastholes resource from AMP that we can see here in the project tree to RMSP. We're also printing the first records of that Blastholes file. We proceed with creating a simple visualization of the Blastholes for documentation. Now we'll define a grid. This is the first time we're using the checkGetResource function, and we simply call the gridDef class from RMSP within the checkGetResource function. In this case, because we don't have a grid definition in AMP yet, we'll create one. So that's the message we get here, creating new grid definition and uploading grid definition to remote. If a grid definition already existed, we would have utilized the existing one. We'll then create a Python object which will contain the coordinates of the slices plotted across these notebooks. We'll use the toAmp to save this Python object in our project. And we can see it saved right here in the project tree. Finally, we'll visualize a plain section of our data and grid. After running this entire notebook, we can see now we have a grid definition file in the project tree and a Python object. We can save this notebook, and let's now take a look at the parameters notebook. The start of the notebook is the same as the previous one, so let's simply run these cells. Now we load the Blastholes file from AMP and load the objects created in the previous notebook, the grid and the slice coordinates. We then move on to variogram calculation and modeling. We are using that checkGetResource function again for variogram modeling here. This is where you see the value of this little function. We've just run this cell, and then we get a message that we're creating a variogram model and it's being uploaded to remote. We now have a variogram model in our project, as we can see in the project tree. We can also visualize that variogram model against our experimental variograms. Now let's right-click and edit this variogram model. Let's push it to the side so we can see our variogram model and our notebook side by side. Let's say we've reviewed the variogram model and now we want to manually set the ranges. Let's exaggerate just so the impact is very noticeable. Let's set the ranges to 1000, 500, and 250. Let's save the changes and let's run the cell again. We now see that we're loading the variogram model from remote because a variogram model object already exists in AMP. Let's run the next cell just so we can visualize how this variogram model has changed according to our edits. So we can see it's quite different from what we had before. Again, the checkGetResource function gives priority to resources already in AMP, or create the resources via RMSP script if they don't exist yet. This allows you to edit a variogram model or a search and so on dynamically in AMP and carry those changes forward in your workflow, instead of always overwrite and utilize those initial parameters defined in the RMSP script. Let's close this here, and now let's delete this variogram model because the change we've made is not correct against our data. Let's go up again and run this cell again to recreate the variogram model and this one just so we can observe the change. We can clearly see that in this case the original variogram model is a better match to our experimental variogram and data. Now we follow with creating the estimation search and plotting that search against our data. Like we just did for the variogram model, we can also edit the search dynamically. So let's view our scene and drag and drop the search wireframe to the scene. Now let's open the search and edit it. Let's put it here to the side so we can visualize our scene in 3D and our search at the same time. Here you are able to edit the angles, ranges, minimum and maximum composites, and so on. If we edited the search here, this edited one would be carried forward in our workflow. So let's do an exaggerated edit just for visualization. I'll change the azimuth to 90 degrees and the major search range to 200. So we can see it has changed quite dramatically from what we had set up before. Now going back to our notebook, we can visualize those same edits in our static plot over here. The search is now loaded from remote and we can see the edits we've just made. So the first angle is 90 degrees and the first range is 200. And we can see those changes in our static plot as well. So it matches our new edited search. Let's go ahead and delete the search, as it clearly does not match our data well. And now quickly recreate it. Now we can see it matches our data back again and we can visualize in 3D to confirm. Let's save our notebook. In the estimate notebook, I'd like to draw your attention to the very end of the notebook. So let's run all of the cells here and go down to the end of the notebook. We're loading our estimated block model back into AMP by using the RMSP.toAMP and calling the models here. We're also creating a pickle file from our Krieg estimator and reloading it back into AMP. So we can see now we have an estimated model in our grid data folder. Let's save this notebook. Moving on to the last notebook, we're running some model checks and inspecting results inline. So let's run everything, all of the cells at once. There isn't really any new AMP element in this notebook, so we're not going to go in detail. Let's bring it to the side here. Let's go back to our scene. So this is quite useful because now we can see all validation results inline in our notebook and inspect our data and the new estimated model in 3D at the same time. In the next video, we'll show how to connect existing RMSP workflows to existing AMP projects. Thanks for joining us in this tutorial video series. We hope this video helped you understand how AMP and RMSP connect and interact. Now it's our turn to explore this connectivity further with your own data and projects. If you have any questions, our support team is here to help.